We've been talking about distributions, and I mentioned that probably one of the most common types of distributions in marketing is the right skew distribution. Okay, right skew distributions are where the vast majority of the data have fairly small values. So there's a right skew distribution shown on slide 39 of your course packet. And so the vast majority of the data fall into one bar, but then you get a very long tail on the right-hand side. So that's a right skew distribution. And I said that you should expect right skew distributions whenever you have a count or an amount. So this video is going to talk to you about what you can do whenever you have such a right skew distribution. So this histogram shows the circulation of about 1,600 U.S. daily newspapers. So my data set consisted of about 1,602 rows, one row for each newspaper, and one of the variables that I measured was what is their average paid circulation, daily paid circulation. And this is a histogram, and it shows that, again, the vast majority of newspapers are pretty small. But then you get some newspapers that are quite large. So 10 to the 6th, recall, is 1 million. So there's a couple newspapers, this would probably be the Wall Street Journal and USA Today, that have circulation in excess of 1 million. And the New York Times is down here someplace, the Chicago Tribune. But these papers are really exceptional in their circulation. Now there's a couple problems with variables that are right skewed like this. One problem is that these values out in the tail, which will be called outliers, can exert a strong influence on analyses. So we're going to see how outliers can influence a mean or a standard deviation. So one value can change the mean in a very dramatic way, and that's not necessarily a good thing. When you have a skewed variable like this, notice how we're using only a small fraction of the graphical space to show 95% of the values, and then most of the space is devoted to showing a couple outliers, and that's not very efficient use of space. Whenever you have such a right skewed distribution, one of the most common remedies or things that people will do is to transform the variable. And we like to have normally shaped variables. And it often turns out that if you take the logarithm of a variable, it will become roughly normally a right skewed variable. You'll get a roughly normally shaped histogram. So here is the log of that same data set, and you'll see that it's roughly normal. So at this point, I want to review logarithms with you, since a lot of students don't remember them from high school. So what is a logarithm? Well, here's the formal definition. Logarithms are essentially exponents. They are exponents. So if y is the log to the base b of x, then x is equal to b to the y. Now that's kind of abstract. It'd be much better, much easier to understand logarithms with a simple example. So one of the common bases for a logarithm, in fact it's called the common base, is base 10. So what I've done in this little table is to show you different log values. I'm just counting -2, -1, 0, 1, 2, and so forth. Now in this first column I show the x value that corresponds with these log values. Alright, so let's consider the value 1 for a moment. So what number has a logarithm of 1? Well, the way to think about it is what number, so if I take 10 to the 1, what do I get? So 10 to the 1 is 10. So you could say the base 10 logarithm of 10 is 1. Likewise, if I take 10 to the second power, I get 100. Therefore, the base 10 logarithm of 100 is going to be 2. Now the thing to note about this log table is that for every unit step that we take in log scale, so if I go from 0 to 1 to 2 to 3, so I'm taking 1 unit hops in log scale, what's happening to x is that we're multiplying by the base. So we're taking multiplicative hops. 10 to the 0 is 1, so the base 10 logarithm of 1 is 0. If we multiply that by 10, we get 10. Multiply 10 by 10, you get 100, and so forth. So with base 10 logarithms, in essence, you're just counting the number of zeros after that initial 1. So 10 to the 5th has 5 zeros, therefore the base 10 logarithm of 100,000 is 5. So that's what logarithms are all about. They transform it in that way. So if we go back up to our histogram, these are base 10 logs. So a base 10 logarithm of 3 is 1,000. A base 10 logarithm of 4 is 10,000. Base 10 logarithm of, so this means 100,000, this means 1,000,000. Now, this histogram is preferred because we're making much better use of our space. We're devoting a large amount of space to where most of the newspapers are at. And so most of the newspapers are sort of between 1,000 and maybe 100,000 in circulation. And we're just devoting a tiny amount of space to the outliers out here. All right, so that's what logarithms do. Now let's go back to the fitness data set that you should have read in by now. So if we go to this fitness data set, let's now consider the down payment variable, and we'll generate a histogram of this. So recall, to generate a histogram, we go into Graphs, Legacy Dialogues, and then Histogram. We looked at age previously. I'm going to get that variable out, and let's bring down payment in. And if we generate a histogram, what we will see is that, oops, I think I used the wrong variable. Let's redo that. So Graphs, Legacy Dialogue, Histogram, and let's copy down payment in. So I copy down payment in, hit OK. And the shape of the histogram is clearly right skewed. Most of the data sits off in this left bar. You get a little bit of a bump down here, and then it extends out to about $10,000. $10,000 ought to seem really strange. I mean, who would pay $10,000 down for a health club membership that only lasts 3 years? So that's probably quite suspicious, in addition to being just extreme. Now, to compute a logarithm in SPSS, what we do is go up to transform. We haven't been to transform yet, and we're going to go down to compute. Now, we have to specify a new variable name. That's called the target variable for the log version. So I'm going to give it a meaningful name, such as log down. And if you'd like to give a label for it, you can click on this type in label box. Now I'm going to give it a meaningful variable label, log base 10 of down payment. Now I need to type in a numerical expression. This would be like typing in a formula into Excel. If you're not sure, go over to the function group, and this is probably under arithmetic, and scan through something that looks like a log. And here we go, LG10 sounds about right. I'm going to click on that, and help appears in this box. So the base LG10 returns the base 10 logarithm. So that's exactly what we want. If I click on this up arrow, it brings it into the expression box. And then, let's see, we wanted to do down payment. So I'm going to bring down payment and bring it into that box. Alternatively, I could have just typed down payment. We have a small problem in that some down payments are 0. and we cannot take the logarithm of 0. There is no number that I can raise 10 to such that I get 0. And so if I try to take the logarithm of 0, SPSS will complain. The way that people avoid that problem is to simply add 1. So that way, if a down payment is 0, we add 1. The log base 10 of 1 is 0. So 0 corresponds with 0 again. That's kind of nice. Go hit OK. And now let's go generate another histogram. So let's go back to Graph, Legacy Dialog, Histogram. We'll get down payment out and bring log down in. Go hit OK. And now we get a histogram that vaguely resembles a normal distribution. So if you squint enough, it looks vaguely normal. However, there are a lot of spikes. So these spikes are rather strange. But if you think about it, there's a good explanation for them. So the largest spike is at the value around 2. So remember, 10 to the second power is 100. So there's a large spike of people putting $100 down. There's also a spike out here at a little bit more than 2. This is probably $150 down. This is probably something like $50 down, this spike right here. If we want to confirm that, we could run a special frequency distribution. So let's go back to Analyze. Remember how we get a frequency distribution. Go into Descriptives and Frequencies. I'm going to reset this. We had looked at gender and payment type before. I'm going to bring down payment in. Now, let's go into Format. Under Format, the default is to sort the frequencies by ascending values. So the smallest number comes first, the largest value comes last. Instead, let's sort it by, or order by, descending counts. Now, by checking off descending counts, that's going to ask SPSS to put the most commonly occurring down payment first. And sure enough, it's 100, confirming what the histogram told us. The second most frequent down payment is 150. The third most common is 50. And as we go down, we see that very few people put, for example, $1,128 down. It's an unusual value. Okay, so the point of this module, again, is that whenever you have a right-skewed distribution, you will often take logs. And by taking logs, you will symmetrize that distribution so that you get something that's roughly normal.